the topic for this talk came from personal problem that we had at home. Like we have these tons and tons of digital photos taken with DSLR. And probably many of you also have photos laying around on USB drives taken with just regular digital camera from the times before smartphones and automatic backups. But yeah, for us, there is a little bit bigger amount of these photos than a regular person might have. So currently it's around 5 terabytes and it's increasing. And well, it's because of this person here. She's a freelancer photographer, doing also designs and whatnot. And also she has done all the graphics and all designs for my slides. So big thanks for her, and big thanks for her for providing me this problem that I can solve and talk to you about. So during the past few years, she has taken some pretty stunning photos of dancers, models, children, weddings, food, and whatnot. And until today, she has taken these a few 100,000 photos, over 5 terabytes. And yeah, these photos were just on random external hard drives somewhere lying around at home. And when I moved together with her, I decided that I should fix this issue, have some way to organize these photos and put those somewhere safe. So as said, I'm working as a full stack developer or lead developer or, well, developer at Nordcloud. I've been doing serverless development for over 4 years now, and also doing React for over 3 years now. I live in Jyväskylä, Finland, and work at Nordcloud. And yeah, we are recruiting in around 10 countries around the Europe. Even in Munich, we have an office where we need cloud architects, designers, application development, whatever around the public cloud. So yeah, when I started thinking about this issue and this photo backup, I thought that this is something, should be something pretty simple, because there's lots and lots of these ready-made solutions for backing up the data. So I would just take the files, put those on a network drive at home, and then sync the photos to the cloud somehow. So when I started going through different services, first I thought that, hey, maybe we could use Google Drive, because, well, that's suitable for storing any amount of data. Well, you can get 2 terabytes for 10 euros per month. That's pretty reasonable. But then, because we need more, the next step is 10 terabytes for 100 euros per month. So yeah, no way we are paying that much for storing these photos. Then maybe Dropbox. They are pretty well-known company, storing quite a lot of data. For them, for individuals, the maximum they provide is 3 terabytes. That is, once again, not enough. And the next tier is a team license, where you can get pretty much unlimited data. However, it's 15 euros per user per month, and you have to buy multiple seats, or like multiple users, to be able to use this team functionality. So once again, costing too much, cannot use it. Well then, since I've built a lot of stuff on a serverless on AWS, I thought that maybe S3 buckets would be a good solution. The regular tier for S3 storage is 2 cents per gigabyte per month. So after doing small math, for 5 terabytes, that is 115 euros. So too expensive once again. The Dropbox from these previous three was probably the best solution, or would have been the best solution, but still that would be just the backup. So we could only put the raw images on a Dropbox without seeing the thumbnail. And also the galleries would be quite hard to browse because it would be just a list of folders. That's not really organizing, just dumping your stuff somewhere. And also it was missing some kind of magic. So that's why I came up with the Backup 2.0 solution that includes the magic in between. So after we copy the files on a local network drive, we put some magic in between and then have some kind of photo browser in the end where we can actually browse the photos and see what's happening. The first thing that I solved was the storage for these raw images. And luckily on S3, there's this Glacier Deep Archive that is a lot cheaper than a regular storage. So that's like $0.00099 dollars per gig per month. So for 5 terabytes, it's around $5. So it's super cheap. It's basically unlimited. It's a petabyte scale, which is more than enough. Downsides are that the retrieval price. So if we want to download something away from the deep archive, it will cost 2 cents per gigabyte. And also we would have to wait at least 12 hours to be able to download a single file from there. However, as this is a like long-term backup only for these raw files, it doesn't really matter since we still have those files on a local network drive at home. And this is just in case if our house burns down or the network drive completely fails, then we have some way of retrieving the data from the cloud. So solve the first problem, we can put the raw files in the S3. And at this point, I was quite certain that, hey, this solution might be viable. Like there's some way of building a cheap and scaling backup solution for files and for photos to be able to browse those. So now we have the raw files in a S3, in a deep archive. The next thing we need to do is to extract the JPEG out of the raw. So when you take a photo with the DSLR in raw format, it will actually store the preview image within the raw file. And the idea here was that when you upload the image to S3, we could trigger a Lambda function that will extract the preview image out of the raw file. Then it will copy the EXIF data, like the camera information, the shutter speed, and all that data from the raw image to the JPEG. And then we want to resize the output JPEG to like 2000 pixels. That is enough for a web view to be able to browse those. But yeah, this ended up being a bit too complicated since those EXIF tools and image magics, those require like native binaries. While it is possible to get it running on a Lambda function, I'm a lazy developer. I just wanted to take the easy route here. So luckily I have more than enough Raspberry Pis lying around at home. So I just took one that is actually working as a network drive, or there's just a USB drive attached to this Raspberry Pi. And every night it will scan the drive for a new raw images and then run the exif tool and the image magic to extract the JPEGs from the images. And then we can sync those preview images on a regular tier S3 bucket. So as said earlier, this regular tier S3 bucket, it is 2 cents per gig. But as we are only storing the 2000 pixel wide preview images there, it's only costing around $1 per month. So another success here. So instead of just syncing the raw files in S3, we are now using the Raspberry Pi to resize the image to correct size, and then sync the raw file and sync the JPEG to the cloud. And then, as I promised, some real magic that is coming in form of AWS recognition. That's an AI tool that I can do facial recognition. So you can find the same person from different photo shoots. For example, if I just want to look at myself, I can find my face and view all the photos where I appear. And at the same time, it can also do object and skin recognition. So we can find photos from different occasions, like weddings or cooking photos or animal pictures or children or newborns or Christmas photos or whatever. And what it looks like, it is like finding the persons from the photos. Then it's giving you percentage, like how likely it is that here is humans and persons wearing clothes, luckily in this picture, and there's a water and water port. Then here we have people in a dance pose at the night time. Yeah, but unfortunately, Magic isn't free. It will cost you $1 per 1,000 images. And running it for these few 100,000 photos, it is costing quite a lot. But luckily, we have to do this only once, since we are storing all the information from the recognition to the database. And also we get 5,000 runs for recognition per month. So once we have done the initial data load, the rest will be pretty much free, since there is less than 5,000 photos coming in every month. So now, how the solutions look like. So we copy the files on a network drive at home. Then the Raspberry Pi is handling the resizing and syncing of the photos. Then we have the recognition and a Lambda function and DynamoDB there in the background. And then we have the actual photo browser for the web. And that is built on React and GraphQL. And there's also AWS AppSync handling the GraphQL server side. So this is the tech stack, and this has been claimed to be the cutest ever architecture diagram. So starting from here, we have this lovely lady uploading files to Raspberry Pi at home, and then it will sync first raw images to deep archive, and then preview images on one bucket. After which we trigger a Lambda function that will run a recognition for faces and for objects, and store all the information to DynamoDB. And then in the end, we have AppSync, GraphQL server, and a Lambda function to to generate the results, and then React single page application hosted in S3 bucket. So a demo time. I have actually given this talk maybe 3 or 4 times previously, but until now I've only shown these photoshopped versions of the UI, but now I've actually finished or almost finished the website, so we can see a live demo. So here we can see the website. So this is a React application with Amplify, AppSync, GraphQL, DynamoDB, and whatnot in the backend. And as you can see, I've added here a CSS blur filter. So because these are real images from real photo shoots of different persons and different weddings, so I don't want to show you original images here. So yeah, if we, for example, click here on one gallery, we can see all the photos. Selecting, for example, that one, we can see that here's food, meal, buffet. Then let's find out what other buffet images we have. These galleries contain photos of a buffet, and then here's all the photos that has a buffet. Going here, for example, here we can see that there's an evening dress and tuxedo, and also there's 2 people in this picture, so here and here, or we can also hover over the face. So if we want to if we now want to see where this person appears, well, he is only in this gallery and in these images. And because one of these, a single gallery like this can have like a few thousand photos, I'm using the HTML attribute loading lazy, just putting it on the image tag, and it will do it automatically, the lazy loading. It is supported pretty well on current browsers. I think Safari and Internet Explorer are the only ones that are not supporting it. Firefox is supporting it in the next version that will be published. So here we can see there's lots and lots of photos, but if I browse quickly, it will like lazy load those on the bottom. Let's see if I can find some more examples of more people in the photos. So here, for example, we have 15 different persons. Here, and clicking on one guest from that wedding, we can see all the photos where he's appearing. So yeah, so the total cost for running this all, so the storing the raw images is $1 for a terabyte, so currently it's around $5 per month. Then running the recognition is around $0 and $5 per month currently after the initial run. The preview images, it was around $1 per month, and then a DynamoDB and all the traffic and all that UI stuff, and it's around 50 cents per month when browsing that gallery, even quite a lot. Then I've gotten a few questions like, how long did it take to come up with this solution, and did it make any sense to do it? Well, your own time. It's priceless, but this was a nice practice run, and how to do multiple terabyte backup solution for quite cheap price. And yeah, that concludes my talk. I'll be available whole day on FrontConf Slack. You can find me from the speaker channel. And also, if you want to follow me on Twitter or GitHub or LinkedIn or whatever, use the handler Arto Liukkonen. So thanks.